So good morning, everyone. This is Circular Dynamics lecture number 12 for NEET. And we were discussing some very important points in the previous class. The points were regarding the motion in a vertical circle. And we were dealing with motion not confined to a circular path. That means the body can leave the circular motion if it is allowed to leave. Then we had seen that there are two important terms or two important physical quantities that we must pay attention, which are both dependent on each other. One is the speed or the velocity of the particle. Instead of calling it as velocity, I can call it as speed. Instantaneous velocity, instantaneous speed. The direction is always tangential. And then there is the tension in the string. Tension is always radial towards the center, and velocity is always tangential. These two things are related to each other. We know this by the equation, the second equation, which is the equation in the radial direction. F centripetal is equal to the centripetal force, that will be equal to mv square by r. We have seen, we have applied this equation in one particular case. And that one particular case was, as you can see right now on your screens, the velocity at the lowest point A. And I told you that everything depends on how much velocity I have given at point A. If the velocity that I have given at point A is exactly equal to root over 2gl, is exactly equal to root over 2gl, then what happens? What happens is that the particle goes up, it reaches the point B, which is the diameter wala height. It stops there. The velocity at point B becomes 0. Tension also becomes 0 at the same point. It stops there for a moment, and then it comes back. It again passes through point A, and it again goes to point D on the other side. Again there it stops. Velocity becomes 0. Tension becomes 0, and it continues its journey in a semicircular path. Do we all remember this? Can I have some raised hand as we remember this? These are very important things that we are discussing here. I hope all of you remember this. Online class, offline class, can I have some raised hand that we remember this? Okay, we also found out the tension at point A, B, and D. Tension at point B and D were all zeros, 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 zeros. Tension at point A, we found out using the second equation, the equation in the radial direction, and the answer was tension at point A was 3 mg. So these are the two things, two terms that you must always remember, and you might be asked to find them out. The first one is, what is the velocity at the lowest point? What is the velocity at other points? This would be one of the questions if it comes in your exam. Or the question would ask, what is the tension or normal reaction at these points? So these are the things that we must remember in this analysis. Now, we had done the case when VA was root 2GL, and let us call this case as case number 1. Case number 1, and case number 1, please note it down. Case number 1 was the case where velocity at point A is exactly equal to root of 2GL. I hope everyone is noting this down. This is case number A. No, this is case number 1. Case number 1 is velocity at point A is exactly equal to root of 2GL. I'll give you time to note this down. Please note this down, everyone. This is case number 1. Case number 1. Case number 1, velocity at point A, speed at point A is exactly equal to root 2GL. Once we note this down, we will move on to, we'll begin our class with the next point. The next point is point number 9, which is case number 2. I hope everyone has written this. I'll wait. Case number 1, velocity at point A is root 2GL. Now I would ask you the question. I told you in the previous class that everything, what type of motion this body is going to have, depends on what speed I give it at the lowest point. The lowest point, which is point A. The first case that we did, the first case that we did, the velocity or speed at point A was exactly equal to root 2GL. Now I ask you, what should be the next case? And see, it has got nothing to do with physics. It is all common sense. Tell me, what could be the next case? Obviously, the hint is we are going to deal with different speeds at point A. The first case that we did was speed at point A is root 2GL. What is the next case? Case number 2. Anyone? Any idea? What would be case number 2? What is case number 2? Anyone would like to say anything? What could be case number 2? No one would like to say anything? Okay then. No, still no one? Okay, it's not that difficult to guess. I have taken one velocity. With this velocity, when it is root 2GL, it reaches the point B, does not go any further, it reaches point B. What will be the next case? The next case is like this. Velocity at point A is less than root of 2GL. So basically, what I am saying here is 0 is less than velocity at A, or speed at A is less than root of 2GL. So I'm going to give it a velocity. So I am going to give it a velocity which is not 0, which is not root 2GL. It would be somewhere in between 0, 0. It is 0. If the velocity is 0, nothing happens. It just keeps there, waiting for something to happen. So I'm going to give it some velocity, but it will be less than root of 2GL. Because if it is equal to root of 2GL, that case is already done. So now it is less than root of 2GL. Now use your common sense. And tell me, what will happen if I give it a velocity or speed which is less than root 2GL? And trust me, there is no physics involved there. It's all common sense. Tell me what will happen. Tell me what will happen if I give it a speed or velocity less than root 2GL, and I'll give you a minute to think about it. Think about it. Let me know your answer. Well, I hope you have noted down this case. No one has given me any replies of what will happen in this case. That is not good. If you don't have any replies, that means you are not attentive in the class. Anyways, that's your life. Whatever you want to do with it. So, what will happen if the velocity is less than root 2 GL? Then the simple thing that will happen, if, so you will write it down now, if the speed, and remember it always, if the speed at point A, that is VA, is less than root 2 GL, the mass will not reach point B, and that is the important aspect. It will not reach point B because the speed is not good enough to take it to point B. It will stop somewhere. It will stop somewhere between A and B. The tension in the string never becomes zero. And I hope everyone is noting it down. The tension in the string never becomes zero, and the particle moves in the lower half. And the particle keeps on moving in the lower half. It is as simple as this. If the speed at point A is less than root 2 GL, the body will not reach point B. It will stop somewhere between A and B. The string, the tension in the string never becomes zero, and the particle moves in the lower half. The velocity will become zero somewhere between A and B. And now, let us understand this case, and the best way to understand this case is to give you an example. I hope everyone has noted this down. I'll wait, and then I will write the question. I hope everyone is noting this down. The particle will remain in the lower half. Tension never becomes zero, because tension can never be zero in the lower half. I hope everyone is noting this down. Yes, note it down. Well, I hope everyone has noted down this question, that description, and here comes a question. What I have created this question. You have a mass attached to a string of length L. The lowest point is, I've called it X, just so that you don't get confused. A, B, C, D. You will think that A is the lowest point, B is the diameter wala point. I don't want you to confuse it. Lowest point is X. The mass of this block is M. The length of this string is L. I have given it at the lowest point, at point X, a velocity equal to root of GL. I have given it at point X, a velocity or speed equal to root of GL. My first question is, will it reach this point? If I call this point as Z, since I'm calling it as XY, if I call this point as Z, Z, whatever you call it, will it reach the point Z or Z? Will it reach the point Z or Z? The velocity that I've given, the speed that I've given at the lowest point is root of 2GL. My first question is, does it reach the point Z? What is your answer? Does it reach the point Z? Z, whatever you call it. I hope the question is clear to everyone. I have given it a velocity equal to root of GL. Does it reach the point Z? Does it reach the point Z? No one knows the answer? Does it reach the diameter wala point? I have given the bob a velocity equal to root of GL. Does it reach the point Z? Anyone knows the answer? Please say. What are students doing in the class? Do we have any answer? Yes, and the answer is that it does not reach point Z, which is the sort of middle point, because the velocity is less than root 2 GL. I have given it root of GL. If it was root of 2 GL, it would have reached the point. Root of GL is less than root of 2 GL, and therefore it does not reach the point Z. Do we understand this? Can I have some raise hand that we understand this? Okay. Now the question is, it will reach somewhere in between X and Y. No, it will reach somewhere between X and Z. X is the lowest point and Z is the midpoint. Let us call that point as Y. So it stops at point Y. You have to find out what is the angle where it stops, theta. What is tension at point X and what is tension at point Y. I'll give you a minute to think about this question and then I will solve it. You can remember the result as well, because if this question comes, it will be a straightforward question. You may not have to solve it. You can remember the result. So I'll give you a minute. Think about it. So how will we solve this question? It's pretty simple. Let us first draw the free body diagrams. At this point, weight is mg. Tension in the string is Tx. Right over here, just like this. At this point, tension is here like this, Ty. Weight mg is like this, mg. And we have also seen that we can resolve mg in this component here. And it is very easy to see that this component is mg Cos or sine? This is mg cos of theta. Remember this. And this component becomes mg sine theta. Let us write the equation at point x. At point x. At point x, let us write the equation. Now, what equation will I write? The second equation I will write, because I only need to find out the tension. I don't need the tangential acceleration. So I'll just write the second equation. What is the second equation at point x? At point x, the second equation is centripetal acceleration will be equal to centripetal force will be equal to mv square by r. What is the centripetal force? Upwards minus downwards, tx minus mg. That must be equal to m into v square by L. Do we all understand this? This is the equation at point x. Do we all understand this? The green equation. Do we all understand this green equation? Everyone? Great. Let us now write the equation at point y, the pink one. I will write this pink one in this. At point y. At point y. How will I write the centripetal equation at point y? The inward force is Ty, tension at y, minus mg cos theta is equal to m into v square by r. Here velocity at point y, the velocity is 0. So m into 0 is 0. So this will be equal to 0. Do we all understand this? Can I have some raise hand that we understand both the equations? No one is going to ask you the tangential acceleration. These are the two equations that we have. Can I have some raise hand that we understand these equations? Now what do I do next from here? What do I do next from here? From this equation, I know the value of V. I know the value of V. This V is nothing but root of GL. This V is nothing but root of GL. If I put it in the equation, I would be able to get the value of Tx. Tension at point X. Can you tell me what is the tension at point X? Can you tell me by putting the value of V? Can you tell me what is the tension at point X? Anyone can tell me what is the tension at point X? It is straight away given. You can straight away find it out. What is the value of tension at point X? If I put the values, and yes, the answer will be coming as 2 times mg. 2 times mg would be the answer that you would be getting from this equation. Did you get the answer? Please raise your hands and let me know. Did everyone get the answer? Same answer, 2 mg. By putting the value of V as root over GL or V square as GL, you will get this answer as 2 mg. That is the first answer we have got, tension at X. But now I move ahead and try to find out tension at Y. So if I try to find out tension at Y, I get this equation. Tension at Y is mg cos theta. So far, so good. Mg cos theta. Tension at Y is mg cos theta. But the problem is this theta. This theta is not known. I don't know the value of this theta. If I don't know the value of this theta, I cannot find out Ty. Therefore, we have two unknowns. We have two unknowns here. One is theta, one is Ty. Theta, Ty. Theta, Ty. If I can find out the value of any one of these, either theta or Ty, I have one equation. Let me name this equation so that it becomes easier for me to understand. This gentleman is equation number 1 and this gentleman is equation number 2. So if I get to know either theta or Ty, any one of those, I can use equation number 2. This is also equation number 2. I can use equation number 2 to find out the value of the other quantity. But the problem is, big problem. The problem is that I don't know the value of theta. How do I get the value of theta? That is the next question. If I can get the value of theta or Ty, I would be able to solve this question. How do I get the value of theta or Ty? Do I have any other equation? Because I need one more equation at least so that I can solve that equation and get the values of either theta or Ty. What is that equation is the question now. A minute. Yes, my dear friends, a minute is what you are going to get to think about that equation and note down whatever is there on the whiteboard or your screen right in front of you. A minute to win it. Minute to win it. Minute to win it. Think. Let your brain do the hard work. At the same time, you are also noting down the question, the solution. A minute. And I'll be back with a bang. Welcome back. Well, I hope you have noted down and you have given it some thought. How will I get the other equation? Because if I don't get any other equation, I'm done. Nothing can happen then. Can I get the other equation? Anyone? Well, I can't give you any more time, so I'll have to just go ahead. The next equation which will help me in solving this problem is my equation of law of conservation of mechanical energy. And this equation I am going to apply from x, the lowest point, to y, the highest point. Total mechanical energy at point A, total mechanical energy at point A shall be equal to total mechanical energy at point B. That means potential energy at point A plus kinetic energy at point A will be equal to potential energy at point B plus kinetic energy at point B. Do we understand this? Can I have some raise hand that we understand this, sir? This is good enough. We know this. We know this, sir. We know this, sir. We know this, sir. We know this, sir. And now we are going to do this, sir. But how are you going to do this? So we'll just draw some diagrams. I have to find out this height, h. I have to find out this height, h. I can say that the potential energy, gravitational potential energy at the lowest point, which is x, is 0. If I can find out the value of this h, if I can find out the value of this h, small h, small h. If I can find out the value of this small h, I can find out the gravitational potential energy of point y. Gravitational potential energy of point y. So now the question simply becomes, can you find the value of h? Can you find the value of h? And yes, the answer is you can find the value of h. This total length is L. If I can find out the value of this part, if I can find out the value of this part, I will find the value of h. And the length of this part from trigonometry is L cos theta. Remember, this is L and this is theta. If I just draw a small diagram here, on the left hand side, if you can see, my dear friends, this length is L, this angle is theta. Go back to your first class where we studied trigonometry. This length would be equal to, this length will be equal to L cos of theta, and this length would be equal to L sine of theta. Do we remember this? Yes or no? Please raise your hands and let me know. Yes, sir, we remember this. This is as simple as it gets. This is as simple as it gets. I have drawn what? Oops, what is happening here? I have drawn the yellow diagram, the yellow diagram, the yellow diagram here. This is L. This angle is theta. This side becomes L cos theta. The other side becomes L sin theta. I just now need to put the values at the points which I'm going to do, and the rest I will leave for you to solve, because I'm not going to waste any more time in solving it. Why is a problem here? Okay. So I will now move ahead and put the values, and I hope everyone understands this. The potential energy at point A is 0. We all know this. Plus kinetic energy at point A. Kinetic energy at point A half into M into V squared. V ka squared is G into L. Do we understand this? Can I have some reason that we understand this? Yes, sir, we understand this, sir. Raise hand will give you more confidence that we are on the same page. Great. That will be equal to potential energy at point B. Now, how do I find the potential energy at point D? This is mg into h. Mg into h. What is the value of h? H is L minus L cos theta. Do we all understand this? Can I have some raise hand once again? Can I have some raise hand once again? Yes, sir, we understand this. Plus the kinetic energy at point B. The kinetic energy at point B is 0. Kinetic energy at point B is 0. Hence, we arrive at this equation. There are some things that can be cut. For example, M and M, G and G. Wow, L and L, and I have a very, very simple equation. I can find out the value of cos theta from there. Once I get the value of cos theta, I can put it in equation number 2. And find the value of ty. Can anyone tell me what is the value of cos theta from this entire equation, from this entire exercise? Can anyone tell me what is the value of cos theta coming? Waiting for you guys. Get me the answer. What is the value of cos theta coming as? Anyone, give me the answer. And you are right, the value of cos theta will be coming as half, or I can simply say theta will be 60 degrees. As simple as that. Theta is coming as 60 degrees. If I put this equation, if I put this value from here, I transfer it to here, I will get the value of tension at the point Y. From here, if I transfer the value of cos theta from there to here, I will get the value of tension at the point Y, and tension at the point Y would be coming as mg divided by 2. And that finishes my question in its entirety. I will give you time to note down the entire solution. If you have any doubts, please let me know. Welcome back, my dear friends. I hope you have noted down this question. I will again repeat what we have done. What was the question? The question was, we had given a velocity equal to root of GL at the lowest point x. Since the velocity is less than root of 2GL, it will not reach the point Z, the diameter wala point. It will stop somewhere in between. We had to find out that angle, and we had to find out the tension at points X and point Y. How did we proceed on doing this question? On very simple terms, we had proceeded by drawing the free body diagram, drawing the tension, drawing the weight, resolving the weight at point X and Y. Then we wrote the equation at point X, Tx minus mg is mv square by L. From that equation, we straight away got the value of Tx. We wrote the equation at point Y, Ty minus mg cos theta is 0. Why it is 0? Because the velocity is 0. From there, we got an equation that Ty is mg cos theta. We cannot find the value of Ty unless we know the value of theta, or vice versa. Who helps us in this condition of distress? Yes, my dear friend, lock me comes in. Lock me. I love lock me. Lock me comes in, saves the day for us. Oops, wrong color. What I'm doing here? I have crossed it. I was trying to highlight it, but something didn't work. Anyways, so we applied lock me, and oh, okay, now it works. We applied lock me, our old dear friend. Lock me helps us. Total mechanical energy at point A is equal to total mechanical energy at point B. Potential energy at point A, kinetic energy at point A should be equal to potential energy at point B, kinetic energy at point B. Then we just applied simple. Trigonometry. Got the value of H. Got the value of H as L minus L cos theta. I've already explained that to you. We put the values, we get the value of cos theta as half, which is giving us the value of theta as 60 degrees. So far, so good. Oh. Then we just put the value of cos theta in the second equation, and we get the value of tension at point Y. Remember, it is not coming as 0. It will never come as 0. Tension cannot be 0 in the lower half. You already know this on this note. At this very point, at this very junction, I would take your leave, and the class is dismissed. We will continue with the analysis in the next class, and probably we'll be winding up this by this week. In the next class, we will be looking at what will happen. We have seen the case where velocity is root 2GL. We have seen the case where velocity is less than root 2GL. Now, what does common sense tell us? Sir, what will happen if the velocity is more than root 2GL? And that is the case that we are going to study in the next class. In the coming class, we will be studying the case where velocity at point A, speed at point A is going to be more than root 2GL. And then we'll see what will happen. Till that time, I hope you have enjoyed this class. Till that time, the next time that we meet, take care. Have a nice day. If you have any doubts, you can ask. The class from my end is over. Bye-bye.